Hey everyone, this is Coach Henzler, and this is kind of an introductory video to parallel lines and transversals, which is what we'll be talking about now. First things first, I'm going to introduce you to the four main things we're going to be defining today, and then afterwards you'll kind of have an assignment to go through it. The four things we'll talk about are the corresponding angles theorem, the alternate interior angles theorem, the alternate exterior angles theorem, and the consecutive interior angles postulate. And you can see right here the arrows kind of indicate that in order it means that the angles are congruent, 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 and supplementary. And we'll get into that more here in a minute. I just wanted you to see that ahead of time so you kind of know where we're going. Okay, if you'll turn to page 154 in the book, I'll give you a few seconds to do that. We're going to be talking about the corresponding angles postulate first. And every single one of these definitions starts out the exact same way. This phrase right here, if two parallel lines are cut by a transversal. And that's going to be the basis of everything we deal with today and in the days to come. So if these two parallel lines right here and right here are cut by a transversal, and a transversal is just a line that cuts two or more usually parallel lines. So that's all it is. It's a line right here that cuts two or more usually parallel. They are parallel in what we're going to deal with, two or more parallel lines. So right here it says the corresponding angles are congruent. And corresponding, in case you do not know, it means the same relative location. So right here, X and X are both on the top left of this quad of angles. They are congruent. They are the exact same. Y and Y are on the top right. Corresponding down here, Z is on the bottom left. This Z is on the bottom left. And then over here, on the bottom right is W, so it is congruent to the bottom right over here because these lines are parallel and they're cut by this transversal. Alternate interior angles. This one states if the two parallel lines right here and right here are cut by a transversal, then the alternate interior angles are congruent. So the two words that we're dealing here with are alternate and interior. Alternate just means different sides of the transversal. So here's our transversal. If you look at it, this right here is a different side from this. So they're going to be on different sides of the transversal. Interior means that if we make kind of a sandwich right here out of the parallel lines, interior angles are going to be one of these four angles inside the parallel line. So either right here or right here. So if we look at the alternate interior angles, we do what's called the Z-test. Do this right here. It's going to be the inside angle right there and the inside angle right here. Or you can do it the other way. Bang. It's inside, bang, inside of that one. It's a little bit different when it deals with obtuse angles because it doesn't look as much like a Z, but you can also think of it as the adjacent angles to the Z. So C and D are congruent and A and B are congruent. Going into the next one, and we're still on page 155, alternate exterior angles. If two parallel lines are cut by a transversal, then the alternate exterior, two key words here, angles are congruent. So these angles are going to be congruent. Alternate again being the outside of, or opposite sides. We could also say the opposite exterior angles, opposite sides of the transversal. And now it's going to be outside of the sandwich made by the parallel lines. So here's parallel lines, bang, bang, alternate sides of the transversal. So we'll go 1 and 8 if we numbered each one of these angles 1 through 8. Or here's our parallel line, so it's exterior and on alternate sides 2 and 7. Alternate exterior angles. And there's a few more examples on page 155. And then finishing up on page 155, consecutive interior angles. So if the two parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. This is where it changes. Everything else has been congruent, and we can kind of tell by looking at them. Oh, those are both acute. Well, they're congruent because of our theorems. If we look right here, we have two parallel lines cut by a transversal. The two key words here are consecutive and interior. Consecutive means the same side of the transversal. We could also just say same side, interior. You'll see it both ways. So right here, interior, it's going to be inside this little sandwich, and then same side. So look at this. It's an obtuse angle, and this is an acute angle. Are these going to be congruent? No, of course not. They don't even look close to each other. So the way we can remember that is if they don't even look like they can be close to each other, but we know there's some sort of theorem or postulate, then by default these two have to add up to 180 degrees, which is called supplementary. These are a supplementary pair. And so it would also be true over here. This angle right here is going to be supplementary with this angle. And it's kind of a, if you get your piece of paper and you label each acute angle with a 1 arc and the dash right here, like this, acute angle with the arc and the dash, and then each obtuse angle with just an arc, you'll see where all the congruent angles lie. Here's an acute that's congruent, acute congruent, acute congruent. And then right here is the obtuse. Obtuse is congruent, obtuse is congruent, obtuse is congruent. It's kind of a cool little deal, and really it makes our lives easier, both as the teacher and the mathematicians, the students performing the math, because if you know one of these angle measures, you can figure out the other 7 very quickly. So that's kind of a cool deal. This is where the video is going to end, and we're going to continue a little bit more in person. Thank you very much.